So good morning, guys. So welcome to the code camp session on MLops on Vertex AI. So it will be presented by me, Neeraj Kumar, and Aman Srivastava. We are from AIML competency from Nasdaq. So let us discuss about the agenda that we are going to discuss. So first of all, we will start about introduction to MLOps. So what are the difference between software engineering and machine learning? What is MLOps, CI/CD pipeline architecture, platforms. Then we will move forward with overview of Vertex AI. Then we will start with the benefit of using Vertex AI for MLOps. Then we will have in achieving how we can achieve this MLOps with Vertex AI. Then we will discuss about the best practices that we need to follow when using Vertex AI. And then we will have a short demo, and then we will start. Then we will have a small question and answer round. Okay. So let's start about what is first we will start about what is the traditional difference between software engineering and machine learning. So at first I would like to ask you guys, anyone in the audience can tell me about what you mean by machine learning? Okay, so silence means no. So no one wants to give the answer. Okay, then no issues. So machine learning is nothing but when we are training our model, and when we know the input, we know the output, but we want to know the algorithm behind that. Okay, in the traditional software engineering method, we know that we have an input, we have a program, and we have an out like a logic that we are using, and we are generating our outputs. Okay, but that's not the case with machine learning. In machine learning, we have a training input and we have an expected output. You can see over here we have expected output, and we are using our some we are doing a ML training, that is known as machine learning training. We are building a model, and that model is based on a model logic. Then we are inferring something from our model, and then we are providing a new set of input. That might be a test input, or that might be the real time input that you want to discuss, and we are getting our output. So that's a difference between traditional software engineering, where we have a program, we have the input and we want the output. While in machine learning, at first we have the input, we have the output, and we are generating the algorithm based on the input and output. Okay. So if I would talk about the aspect or definition, so in traditional software engineering, we are used in order to develop the software systems. As we know, if we want to develop some kind of web application or mobile applications, then those are being developed using the traditional software engineering method. While in machine learning, what we are doing is that we learn from the data, because we have an input, we have output, we define some kind of learning algorithms, and later we are using that for our predictions. Okay. So same way, software engineering will be used to build the software, any softwares, and machine learning can be used to build some predictive models. If we want to know the output, you might have heard like nowadays, if someone has gone for any kind of CT scans or MRI, you might have seen that people used to highlight on the billboard that we are using machine learning algorithms. They are nothing but they are doing just they are using they are enhancing the images using machine learning. Okay. So same way, what are the activities that we generally do? We all know at first when we are doing a requirement gathering, what are the things that are needed? We are doing a coding, we are testing our code. While in machine learning, the first thing that we need to do is that we need to process our data. So data process is the first task that is very important, and then we move forward with our model trainings. So if I talk about the skill set, so for software engineering, we all know we would be requiring programming and a software design patterns that are necessary. In machine learning, first thing that is necessary is mathematics. Then we need to go with programming, and then we need to use some of the predefined algorithms are there, or even we can generate our new algorithms. But with respect to time, machine learning had become so much mature that we have most of the algorithms along with us, and we can directly use it in Python or in R, any language that you want. But mostly people are using Python. If I talk about emphasis, then software engineering mostly used for functional software, while machine learning is used for data patterns, model accuracies, and all. And in traditional software engineering, performance and user satisfaction are the metrics that help us to decide how good we have built our system. While in basic machine learning models, we are using accuracy and precision. And there are other metrics also, but they are one of the two metrics that we are using in order to test how good is our machine learning model. Okay, so now we would starting about introduction to MLOps. So first of all, what is MLOps? Okay, so I think everyone knows about the very big hype that is there in the market that is known as DevOps. Okay, so development plus operations. So the same principle, like development plus operations principle, when they are being applied to ML systems, then that is only known as MLOps. Machine learning plus operations. Same way as we have data ops as well, data engineering plus operations. So whenever we are combine operations or a continuous delivery or some into any systems, then for example, when we applied that to a development system, then at that point of time, we started calling as a DevOps. And same way we have applied that to our data engineering systems, we started calling that a data ops. And same way when we have applied those principles, same principles to our ML system. Yeah, someone is saying something? Okay. So when we have applied the same principles to our machine learning system, so that is known as MLOps, machine learning plus operations. So they are nothing but a continuous delivery and automation pipeline for. So if I want to create a CI/CD or the automation pipeline for our machine learning system, those all principles comes under machine MLOps, machine learning operations. So what is MLOps? So generally MLOps are being divided into three levels. First is the manual process. So in the manual process, we are manually building our model. Deployments are also manual. Uh, because of this manual, our releases are also infrequent. Okay, we don't have any CI/CD. So sometimes there might be a gap between our machine learning and operations. So just we would move to our second level, that is ML pipeline automation. So our ML pipelines are automated. Okay, so it means that the pipeline that we have created in order to create our model, so our model has some continuous model training and delivery. Okay, so this only emphasizes on creating the new data, like only on the machine learning part, not on the other part that we are using. Okay, so we'll move forward with the third part, that is nothing but CI/CD pipeline automation. So iteratively we are testing new ML algorithms. We are creating a new models. We have some kind of I would rather say accurate some kind of evaluation metrics been prepared, because of which we would get to know whether that particular model is good or not, and based on that we will deploy our model. And how this orchestrate experiment steps, like we have pushed our code to a repo, and on our push only there should be some kind of, like our commit only there should be some kind of build test, and we're producing a pipeline. So this whole CI/CD pipeline automation is the third level of MLOps. So at first I would discuss about the CI/CD pipelines. So machine learning operation helps us to integrate the ML development, so development life cycles, deployment that we are using, and the maintenance. So if we are using CI/CD pipelines, then it may help us to automate the tasks, manage versions, and mostly increases collaborations. And same way MLOps help us to enable CI/CD pipeline. So if we have created a CI/CD pipeline with MLOps, then we can use those CI/CD pipelines for our model iteration, and even we can use for our deployment. It helps us to monitor, log, and performance track of the different models that we have created. Okay, so obviously because of this, we would have a teamwork between our data scientists and engineers, and it also help us for better for best practices and all. So for example, we have a development life cycle, we have a planning life cycle. So in the development and planning, we are defining our problem, we are doing our data collection, we are defining the steps, we are just defining the steps for model development and the version control. Then we have a CI/CD step. So for CI/CD is for continuous integration, and over here we have a model deployment and then continuous development. And after we have CI/CD, we have a monitoring been set up on the top of the model that we have created. So monitoring and login, feedback loop and model updating, and scaling and resource management. This all things comes under monitoring and management. So this is the whole CI/CD architecture that we are going to use. So we have a cloud build. Cloud build is nothing but a CI/CD tool. Like we have a GitHub Actions. Same way we have a cloud build, which is present in GCP. So once we push our code to GitHub, we have a trigger being created in our cloud build, which will create and push image to artifact registry, execute our pipeline. Then our code is there in the artifact registry. From the artifact registry, we'll push our data. At first, we will process our data. So in the processing layer, we will fetch the data set. If our data set is in the over the GCS bucket, we will fetch the data from the GCS bucket, and we will store the output in the output part that we have defined. Then on this particular data, we will fit our model. So the type of the model that we are using, we will store the model to our GCS bucket, and that will be the model output part. Then after that, we have an evaluation phase of the model. In the evaluation phase of the model, we will get the model part. We will calculate the accuracy and all the other matrices that are needed. If we have some kind of images that we want to save, we can save that to our GCS bucket. We have output nodes, what are the outputs that we want to show. Then we will upload that model. Up to here we have evaluated the model. If the model is good enough for the deployment, we will upload the model, and for uploading also we'll be using a cloud build, and we will push that to our artifact registry, and then this model will be using as a serve model. Serve model refers to the fact that we will have this model deployed as an endpoint where a user can come and can use REST APIs in order to hit the endpoint and can get the output. So this will work as a server endpoint. Okay. So this is the whole CI/CD pipeline architecture that we follow for our MLOps. Now, what are the different platforms and tools available for MLOps? So we can use Kubeflow. So Kubeflow is nothing but an ML workflow management on Kubernetes. Okay. Then we have some kind of open source tools, like MLflow is one of the open source tools. So it is used for end-to-end ML lifecycle platform. We have a data version control. So DVC is used for data version control. We have a Metaflow is also one of the Python library which help us to which helps us for MLOps in Python. Then we have Apache Airflow. Airflow is nothing but a tool that is used for not only for machine learning pipeline orchestration. You can orchestrate various kind of jobs, but we can use Apache Airflow for our machine learning pipeline orchestration as well. Same way we have a Sheldon code, which is used for ML model deployment on Kubernetes. So these are all the open source tools. Then if I would talk about the cloud alternatives, then we have Amazon SageMaker. So SageMaker is one of AWS managed services which is used for which is a MLOps tool provided by Amazon. Same way in Google Cloud we have Google's ML suite. Over here only we have Vertex AI, which is a tool provided by Google Cloud. And same way in Microsoft Azure also we have Azure cloud-based ML lifecycle services. Okay. So now let's start about Vertex AI. So we will be in this particular session we'll be focusing on the Google provided solution for MLOps, and that is nothing but Vertex AI. So overview of Vertex AI. So what is Vertex AI? So same way as I have talked about MLOps as a whole, or then same way Vertex AI is a tool for MLOps. So it will help us for building, training, and deployment of our ML models. And basically, since it's a managed services provided by Google, so it will help us to integrate Google Cloud services easily for streamlined workflows. And as we have told that it supports auto ML, that is auto machine learning for easy model creation, and it helps us to provide MLOps capabilities for managing ML lifecycle. So and the best thing about Vertex or any managed services, you don't need to think about any kind of infrastructure management or autos or should I need to increase my load or decrease my load or auto scaling, any type of scaling and all. This all things are scalable infrastructure is provided by Google itself, and you just need to focus more on our logic side and less on the infrastructure building side. Okay. So it offers scalable infrastructure for ML experimentation and deployment. It helps us to enable collaboration because it has some like the same way it enables collaboration and version control. So this all things are pre-provided by Vertex AI since it's a managed services, and it simplifies our AI deployment. it has some kind of pre-built models and pipelines which help us to simplify our AI deployment. Okay, so what are the different features provided by, if I would talk about Vertex AI, then in the Vertex AI, we have a model garden and a collab enterprise. Okay, so what is the use of the model garden? So in the model garden, at first we have a pre-trained model repository. So it's not necessary that like with respect to the enhancements or I would in machine learning overall as a whole, machine learning domain. So we have most kind of pre-trained models, and we can directly use those models for our own machine learning tasks. So in the model garden, we have pre-trained model repository, and even over in the pre-trained model repository also you can use your own implementation which is available. You can either go for TensorFlow or you can go for PyTorch. Even it help us for rapid prototyping and transfer learning. So all these things are provided under model garden. Like we have a training, we can store our metadata is stored in model garden. All the experiments that we are doing are being stored in model garden. So we can encourages collaboration, stays update with the latest research. Same way we have a collab enterprise. So secure and enterprise version of Google Colab. So we all know that Google Colab is one of those which we can use for our coding and in order to use the machines or GPUs and all. So when we are using Vertex AI, we have a secure enterprise grade version of Colab, and it seamlessly integrates for our GCP platform. It supports collaboration, and even we can create our custom environments over there. So all the data sets, data labeling, feature store, all these tasks are being done in Collab Enterprise, and it enables efficient resource management and offers enterprise level supports. Okay. Then we have then the best thing about Vertex is about the model registry. So we have a model registry. So inside the model registry, we can it's a centralized repository if we want to store or version our models. For example, if we're doing some kind of experimentation and we are using hyperparameter tuning in order to find the best model, so we can store our models in our model registry, and based on the best model that we want to serve, we can use that particular model as our endpoint. So so model registry is nothing but a centralized repository for storing, versioning, and managing the ML models. It helps us to facilitate organizational and tracking of model versions and metadata. And there is a seamless collaboration because since we have a model registry, so and as I told you, Vertex is a managed service. So we have a streamlined collaborations between deployment and workflow for the teams, and it enables easy sharing and discovery of the models. Same way, we have one more features of this, that is online and batch prediction, that we have told that we can deploy our model and when we can use that particular model as an endpoint. So we have a real-time inference service for deploying and serving ML models. It provides low latency predictions on live data for immediate insights. It means we don't need to manage anything. Like this, all things have been managed by Vertex AI. It efficiently handles bulk inference tasks, optimizing resource utilization, and we have a high throughput inference service for processing large input counts. So these are the four features of Vertex AI: Collab Enterprise, Model Garden, Model Registry, and Online Batch Predictions. So now I will ask Aman to explain more about the benefits of using Vertex AI for MLOps. Uh, Aman, over to you.
Okay, thank you so much, Neeraj, for explaining so far this well. Let me share my screen and continue. So I hope my screen is visible to all.
Yeah, Aman.
Okay. So continuing with the fact points of benefits of using the Vertex AI. So before we discuss about the benefits of the Vertex AI, let's say what are the challenges that we used to face or we can still face if we do not opt to the Vertex AI right now. So that we have to face some complexity in the management of our code. Like it is very difficult to handle some aspects of a process that especially when it comes to the multi-stages, which has their own complexity. As if we talk about the interpret issues, so we have to ensure that the different integration stages are there. So it might be assured that whenever we are integrating some of the components, So we might be hindered by some fact that various systems might not communicate with each other due to some protocols or some formats of the data. So we talk about the scalability concerns that we all know that our input to users can be increased or decreased by over the time. So it is very important thing that we have to handle that whatever the model is predicting or whatever the service we are providing, that we have to ensure that it never goes down. So these kind of challenges we have to face, and as in the customization challenge, we have to specifically write down some code, or we have to specifically solve a particular use case meeting our own requirements or the client's requirements. So as in that case, we also have some challenge over here as in the consistency maintenance. So suppose if we want to do some upgrade, or we want to solve some issues in the code, or we want to create a new feature in the particular solution we are already serving. So that might be a complex issue there that we have to iterate over the particular issue, or we have to identify that in which phase of the particular pipeline we have to involve this particular feature. So that's how we used to face all the challenges in this before using the Vertex AI. So how it has overcome by using the Vertex AI? So since our solution is being curated with the end-to-end solution, we have all structured proper. We have properly structured our all steps from the beginning of the data processing to model deployment into subparts. Like every step is defined into its own environment, which has its individual code. So either we want to make some changes, either we want to make some new feature implementation over there. We do not have to hinder about the where should we implement a particular change. We have our hierarchy, we have our DAG over there, that particular model is over here, particular component is here. We can simply integrate our changes over there, and we can go on with the process and let it run. So that's how end-to-end solution helps it. So as in the points I have mentioned over here, the simplified implementation is provided. We have the improved integration that the components when they communicate with each other. So we can define whatever the data formats we are supposed to pass to the next component, that it will be able to read it or not. So the steps are defined in their particular manner. So we have some complexity. We have reduced some complexity over here also. As in, if we talk about the improved security, like every component is isolated within its own cluster. So we are integrating it with the environment, as if we are integrating with the GCP. So we have defined some rights, or we have defined some particular authentications that a particular component is only able to access those particular operations, and it won't be able to compromise any other operation over our GCP accounts. So that's how we can leverage it. And as in the reduced costs, we can actually monitor it uh, by mentioning our metrics over the pipeline. Suppose you have 5 components, and every component has some different kind of task, and it uses some different type of computation power. And that computation power, especially when it comes to utilizing the machine. So we can define our machines over there that this particular task will be requiring this kind of particular machines. So we won't have to commonly define a particular machine that will be utilized by all the components. We can simply differentiate it based upon that task. So that's how we can also focus on reducing the cost of our pipelines. So moving forward with slides, as in the monitoring and optimization. This part is comes into the major aspect, like when we are done with our pipeline, our model is finally deployed to an endpoint. What about the current situation, that how model is performing, how well it is serving to the customers. So over there, we, as Neeraj said in our slides, that we implement this on the top level of a model deployment or of our pipeline. So there we define some metric, or we define some flow, like we can say that we define some feedback pipeline over there, that we will be logging every input instances and the performance of the or the accuracy of the model that model is giving to that particular instances over our monitoring dashboards so that we can actually observe that how well our model is performing in the real time. So either we have to make some changes or not. So as we can see the points mentioned over here, we can log our precision, recall, accuracy, and advanced. These are the model evaluation metrics used in our machine learning. As in the resource utilization, suppose we are using some GPU or some CPU. So whatever the choice we have made and how much it is being utilized over the real time, and that we either it is affecting our budget or not. So as in the data driven detection, we identified that a particular model has been trained on some particular data, but now model has been facing some new kinds of input, and now it is not able to predict correctly. So that kind of situation comes in the data-driven detection. As in the model-driven detection, suppose model we have detect some model is not making the expected output, or we are not getting the exact output that we are supposed to get. So that comes in the model-driven detection. As in the auto scaling, we have discussed like it is able to handle the workloads whenever it has to increase the count of instances or not. So that comes in the part of the auto scaling. As in the experiment training, as we have earlier also mentioned, that whenever a model is trained, we use some hyperparameters over there, that what will be the learning rate, what will be the step size, the model will be utilizing over the training period. So that is very necessary that either we want to make some changes in the model, that we have to make sure first that earlier what are the metrics, what were the matrices we were using to train our model, and how can we take it right now so that our model performance or model accuracy can be increased. So as in the cost monitoring, Vertex AI also provides us the feature that whatever the instances are up right now, we can monitor the cost of the particular instance on the daily basis, that whatever the how many requests has been made to that endpoint, or whatever the cost it is giving us. So that's how Vertex AI also provides us this facility of monitoring and optimization on the top level. Moving forward, that we in this achieving MLops with the Vertex AI, we will discuss how we can actually curate this whole pipeline from end to end in the Vertex AI. So as in this phase, we will be actually utilizing the Kubeflow. Kubeflow is basically, it is an open source platform which provides us a simple or integration with the ML pipelines, where we can simply deploy a model, create a model, and we can easily serve a model to an endpoint. As we can see here, we have our pipelines options over here is provided by the Kubeflow. We have the notebook, as we have mentioned over the GCP is collab. So it also provides us some notebook that we have the VS Code, we have the Jupyter, whether whatever the choice we want to use, we can leverage it. As in the model training part, we have the frameworks like TensorFlow and the Python. Whatever the frameworks we are supposed to use, we can utilize it. As in the auto ML part, we can just simply pass our data as an input and train the model in the easy steps. As in the case of case of it easily provides us the part where we can simply deploy a model over the Kubernetes cluster using the Kubeflow framework. As in the monitoring dashboard, we can actually monitor whatever the matrices are generating over the real time, whatever the feedbacks we are getting. So that's all the benefits we get from the leverage Kubeflow. As in the parts, we will discuss like portability issues we are overcoming here. So as in Kubeflow, we can integrate a Kubeflow using any cloud environment. Like if we want to leverage the Kubeflow using the GCP or using the AWS or using the Azure, we can simply integrate a Kubeflow framework into that. We do not have any restriction that it is only limited to the GCP. As in the reproducibility, as we all know, or that I should mention that Kubeflow has the reproducibility and the standardizing ML experiment, like the experiments are containerized into an environment. So whenever the containers is somehow get destroyed or some issues are there, that it has also have the capability of healing itself. That particular container will be recreated. And in the workflow orchestration, we can simply streamline our whole workflow from end to end, step by step, so that we can easily visualize that whatever the steps or whatever the processes we are going through in creating our solution. As in the model serving, we can simply easily deploy a model using the clip flow model serving capabilities. As in the experiment and tracking, we are simply tracking our feedback matrices, feedback loops are over there, whatever the input we are getting from the users. So that's how we can leverage the clip flow over here. So moving forward, let's talk how it works actually in the Vertex AI. So as in Vertex AI, suppose we have some 5 steps, A, B, C, D, E, and we have defined in our code A, B, C, D, E, and we simply want to compile those particular steps into our definition, where as in this, we define our components over there. We compile that particular components into a JSON file where that JSON object will be utilized to create our whole pipeline solution over the Vertex AI, so that it what it actually benefits that our components are not being containerized into an image. We are just simply defining those components into a JSON file, and whenever the pipeline will be executed on that real time, this particular pipeline will fetch that pipeline JSON file to execute our pipeline components. As we can see here, we have defined some steps over here. So from this step to this step, we know that every component dependent upon each other as we see the graph. So the basic idea is that whenever these components are executed, these component have its own environment, this have its own dependencies. So whenever it is executed, once it is done with the task, that particular component is destroyed. So we are not holding up to that cluster, or we are increasing the cost. So that's how our cost is also getting affected over here. We are actually decreasing it. So one by one, when the steps are executed, suppose what this step is done, this step is done. So these clusters will be destroyed, and it will move to the next component since our pipeline will be completed successfully. As we also have the logging feature over here. Suppose we have some step, as in the ML aspect. If we talk about some images, we want to log some graphs, want to log some evaluation metrics over here. So we also have some basic nodes over here, like as you visualize through it, we can easily put our nodes over in the pipeline deck. So we can easily track that whatever the evaluation has been generated over there when we use that when we executed that particular pipeline. So that's how our whole pipeline is compiled into a definition, and the definition is basically representing our whole pipeline into a DAG using the Vertex AI. So moving forward, let's talk about the best practices and the recommendations that we should consider whenever we are creating this kind of solution. So first we have to be very clear with our objective, that what are we actually trying to implement and what are the basic or necessary steps that will be required. So we cannot easily just define our components into various steps. So as we discussed, that component is encapsulated within an environment into a cluster. So every cluster will be costing some amount over there. So we have to identify that how many components will be there to build our complete solution. As in the data management and the versioning, we have to ensure that the data we are using to train our model. So, and whatever the data we are changing by the period of time. So we are keeping the track of those data sets or not. As in the model development and the version control phase, whatever the model we have trained so far and how we are managing those versions of the model using the model registry over the Vertex AI. Either we are tagging some text over there, as in the experimentation and the hyperparameter tuning part. We have to ensure that whenever we do some kind of whenever we execute these kinds of pipeline, we have to make sure that every particular hyperparameter or every experimentation, every metric that we are utilizing over there should be logged over the Vertex AI pipeline, that we will be able to track it in the future to improve our model performance. As in the automated pipeline and deployment, we have to simply streamline this whole code, that whenever we make a change, that particular pipeline will be executed, and our whole execution will start in a second, and it will reach to our end solution, by which it will be giving us an endpoint, so that model will be available in the real time to as a service to the users. And so on, moving with this, as we also have to consider about the monitoring and logging. So whenever the model is being deployed, it is being utilized by the users. So whatever the instances, whatever the logs we are uh, creating over there, it should be stored over a particular data source, that it also has to be secure, that we cannot just simply logs that particular data into a file, that it can be utilized sometime in our whole future steps, or the whatever the process that we want to execute based on the previous metrics. So that we also have to consider. As in the security and compliance part, we have to ensure that whatever the data set, whatever the models, whatever the whole artifacts are generated over this whole execution, those are particularly secured using the GCP secure environment, that we cannot simply make it public that our data set is over there. Some personal information can be over there in the data set, and the model can be there. So we cannot simply make it public. We have to ensure that our whole execution is safely incorporated and it is secure. And as in the documentation and the knowledge sharing part, we have to ensure that whatever the steps we have defined so far, whatever the services of GCP or any other cloud platform we are utilizing over here, are documented into a particular file or documented properly, that we whenever we want to give some KTU knowledge sharing to the particular person, that he or she might be able to adapt those steps and go on with those particular steps. So whenever they want to collaborate with us or they want to make some changes, they do not have to be rely on some candidate, that a particular candidate is aware about this backend that I am not. So we have to make sure that whatever the execution we are doing, we have to document those in a proper manner. As in the feedback loops and the model iteration, as we have discussed, that when the model is serving in the real time, we have to make sure that our testing phase is there, that we will be testing our model by passing some input instances, as it can be test data or some new inputs that model has never seen. So we can identify that model is performing well or not. As in the performance optimization, whatever the latencies we are getting, that model is able to perform in the required time or not. So these are the aspects that we have to consider whenever we are creating our whole MLOps pipeline. So let's quickly move to our demo. So let me first walk you through our code. So as we can see here, we were discussing about the pipeline definition. As we can see here, here is a pipeline where I have defined our all steps from basic steps of fetch data, where we will be simply fetching a data from the GCS bucket. And then we will be passing that particular fetch data from the GCS bucket to our next component, where we will be pre-processing the data. We will be applying some feature engineering. We will be cleaning some NA over there. We will be actually uh, analyzing our data and creating it suitable for the model training. So when it is done, then pre-processed data set it passed to the fit model part. As in the fit model part, whatever the model we want to create, that particular algorithm will be utilized. So as in this phase, we will be getting this pre-processed data from over here. And as in the fit model part, we will be creating our model and logging it into an artifact. So as we can see here that we have defined our memory limit over here. As we were talking about, we can simply define our components with the each machine type, that whatever the instance type it has to use to perform that particular task. So we are demonstrating it through the memory by passing the memory limit over here. So that particular cluster of fitting the model will be utilizing that 16 GB memory over there. As in the model evaluation, we will be evaluating the performance of a model, that a model has meeting our requirement or not. Since if the model meets our requirement, then only we will move to the upload model task. And if it does not, then our pipeline will be break and we will be notified that our model has not meet our requirement. So we have to reiterate over that whatever the model we can begin with again. So when the model evaluation is done, our upload model task will be executed over the pipeline. So what it does, it basically it creates an image, which image will be consisting of our model and the inference code. and that particular code will be deployed over the GCP environment of Vertex AI. So when this image is uploaded to the GCP artifacts, so that image will be utilized to serve our model into an endpoint. So this is the pipeline definition that we have created so far to demonstrate our MLOps solution. So what actually happened whenever we commit this code will be triggering a cloud build, and that cloud build will be, let me show you this particular cloud build as we have mentioned execute pipeline over here. So as you can see, it is linked to a GitHub repo, and it has been indicating the trigger function like whenever the code is committed push to a branch, some new changes are committed over there. This particular trigger will be executed, and it will be reading our whole configuration through this cloud build YML. As you can see in the cloud build YML, I've defined all the steps what it has to do. So first of all, it will be installing our requirements, whatever the necessary dependencies we are required. As in the next step, it will be creating our image. As in the next phase, that once the image is created, it will be pushing that particular image to our GCP artifact registry. As in the image name, we have passed the whole path of the artifact registry. As in the upload details, what we are doing over here that we have made some commits, and we want to, as we were mentioning in the presentation, we want to track the whole flow that whatever the pipeline we have executed, we should have that particular logs in there. So what we are doing here, we are logging our SHA. So whenever we make a commit, a particular commit hash is generated, as we all know. So that particular hash will be appended with our image tag, so that we can easily track that, yeah, particular pipeline has been executed with this particular hashtag. So that's how we are tracking it. Once this pipeline file configuration file is created, it will be uploaded to our GCS bucket, so that from that GCS bucket we will be using this pipeline configuration file to execute our next steps. So as in the next step, it is executing the pipeline.py as we have defined over here. So what it will do, it will compile all our components into a definition and create a JSON object over there. And once that JSON object is created over there, it will push that particular JSON object to the GCP bucket. Once it is done, it will now execute our pipeline run. So what over happens over here, that pipeline run is simply getting the path where a GCP has pushed our pipeline configuration as a JSON object over there. So what it will do, it will fetch that particular JSON object, and it will submit our pipeline over the Vertex AI environment. Once it is done, what it will our first cloud build process will be completed successfully. So let us try now. We want to make some changes, like obviously we want to handle some changes over here, like nothing test pipeline changes. Now, since we can track this, as let me walk you through our code. So here is our pipeline, as in the constants, we have nothing over here. So I have made some changes. Let me try this. Yeah, constant. Let me add constants. I committed, suppose we are going to mention that test my pipeline. Yeah. So let me push it now. So our changes has been committed to our repo. Let me refresh it. So as we can see here, our test pipeline changes is done. And what we were expecting, then once the commit has been done, our trigger should be triggered. Let's see in the history. Yeah, our trigger has been started executing, and the submission time is 12:15. As we can mention over here, 12:15 is the current time. And our trigger, the moment we have committed our changes, the trigger is executing our steps. And the steps we were discussing about that: install the requirements, create an image, push that particular image over the GCP, create a pipeline configuration file, then push that particular configuration file over the GCP, run our pipeline and compile that pipeline into a JSON object. Then simply submit our pipeline. So once these all steps will be executed, it will simply submit our pipeline over the Vertex AI. So this process might take a little bit time. So as we can see, we are able to see all the logs over here, that whatever the dependencies here. So let's just go through the next step. What it will be doing, it will be submitting our pipeline. So let it execute. For the demonstration purpose, I will walk you through the pipelines. So as in the Vertex AI, we have the option of the pipelines. So let me refresh it again. As for the demonstration, once this cloud build will be done successfully, we will be seeing a new pipeline with a particular ID over here being executed. Since this process might take a little bit time, let me walk you through the old one. So as we can see here, once that particular first cloud build is executed, it will be submitting a pipeline like this. Since we can see all the steps are already executed over here successfully, what will be actually visualized over here, that from the beginning, it will be starting from the fetch data. As that particular fetch data will be executed, then only it will pass to our next pre-processed data component. So as we are talking about the nodes, we can log into our pipeline, that we can see the particular nodes that we have passed the dataset path over here. We can see whatever the dataset we are using, and in the next node we can see whatever the pre-processed data we have over here. As in the FitDB model part, we have logged our model into an artifact. So we can actually see that model is logged over the artifact, and we can locate it. As in the evaluate model performance, we are logging two metrics over here. Once it is a cluster image, that particular cluster image, how many clusters are formed. So it is the ML clustering model. So we are forming a cluster image over here, and we have the evaluation score over here. As we can see, the score is over here, the 0.84. So we are logging our nodes and logging our metrics into our nodes. So as we were discussing, we can easily visualize that whatever the metrics or whatever the steps we have incorporated into a pipeline, we can simply visualize it through this DAG. So once the evaluation phase is done, it will trigger the upload model. Here, what upload model is do, it just simply triggers a new another trigger, cloud build trigger. Whatever that, yeah, we can see over here. Here we have our another build trigger. What it is doing, it is the serve model trigger. As we go through the path of this particular trigger, here we can copy the path, and what we have done here in the code, we have passed this particular trigger path. So in the upload model phase, that particular component will be executed. It will trigger this serve model component, serve model trigger. As in the serve model trigger, we have seen that as this was our submodel cloud build. As in the submodel cloud build, what it was doing, it was simply creating the containerizing our serving code where our model was there and the inference code was there. Let me show you in the code. As in the serving container, we have our submodel part over here. So what we are doing here, we are downloading a particular model from the artifacts, and we are just simply reading and simply serving it using the Flask app over here. So this is our inference code. And to to let this particular sub model part execute successfully, we have defined another cloud build configuration over here, as the steps are defined over here, and we have created this Docker file also there. So this will be executed once our second cloud build is done successfully. So as we can see, our first cloud build is done. Let's take if our new pipeline has been submitted. Yeah, we can see over here, our new pipeline has been submitted. And now once these steps will be executed, it will simply deploy our model to an endpoint. So as we can see here, this pipeline is running, and second cloud build, we have already discussed that second cloud build will be pushing our image over the ACP artifact registry. As in the artifact registry, we can see in the clustering pipeline, we have the different artifacts like in the DB scan image. These are some trials we have done. So we can see over here that particular artifact is derived from the cloud build. So as in the pipeline, once our upload model is done, it will be executing the serve model component. As in the serve model component, we are also logging our metrics like the Vertex AI model, whatever the model version is utilizing over here as in the endpoint. Whatever the endpoint we can utilize to make our predictions. So we can see over here simply the endpoint ID is passed over here and the path. So as in the online prediction, we can see, let me refresh it again. Yeah, so it is a DB scan model endpoint. What it is doing, that particular endpoint is served to an that particular model is served to an vertex AI endpoint, and we can simply make a prediction using this particular endpoint. So let me just for the demonstration purpose use a simple estimate app. What it is doing, it is just simply here we are simply passing the input instances. As in the input instances, we can see whatever the input instances we are ending over here. So these are some basic features that we want to identify that either it is an outlier or not. So let's detect an outlier. So what this estimate app will do, it endpoint not found as in the DB model endpoint. So okay, so what it is doing here that as in our code, we used to automatically fetch this particular endpoint, DB scan model endpoint, since someone is already deployed and model and this particular new endpoint has been there somehow. So our demo has been making some conflicts over here. So what it actually does, whenever we, let me just give you a walkthrough. Whenever we make a prediction and do the submission, so as in the feedback loop, what we do over here that we actually pass the true as in the true or false that yeah model has predicted this particular input instance is correct or not. Once that particular input instances is done, we submit this particular input feedback into our BigQuery dataset. As we can see over here, as in the testing history dataset, we have a response table. Since for the demo, I have made a submission in the morning, like last modified version was the March 18. As in the preview, we can see, as in the prediction that model has made, it has the global reactive power, global, as in the response model has made not outlier, and the feedback we were providing to the input instance that yeah, particular prediction is true or false. So it will be generated over the BigQuery over here. So once this BigQuery table is generated of our feedback loop, what we were actually doing, we were utilizing the cloud function. And that cloud function, what it was doing, it was fetching this particular table from that BigQuery and creating all the possible matrices like accuracy, F1 score, precision, recall, whatever the interquartiles were there. And we were logging all those metrics back to the metric table. As in the metric table, we can see, take a preview. As in the metric table, we have submitted a two metric over here that whatever the accuracy, precision, recall, mean reactive power, standard reactive power, mean intensity, standard intensity, F1 score, confusion metric, the how many true positives are there, how many true negatives are there, and then the IQR intensity, all the possible metric that we can generate. So we were logging all those into the BigQuery over here. So that's how we were orchestrating our whole flow from a commit to the model deployment into an Vertex AI pipelines. So that was all the points that we have covered so far in the MLops. That was all from the my side. So moving to our Q&A part, I think we can begin with the any query if anyone has.
I guess so no one is having any queries as of now. So we'll appreciate if you guys can, if you are having any queries, then you can always reach out to Neeraj and Aman later on Teams. So with this, I guess we are good to wrap up from here. So thank you, Neeraj, and thank you, Aman, for delivering the session, and thank you all the attendees for joining in. We'll be rolling out the assessment forms, so it's a request, a sincere request to each and everyone who has joined to kindly appear in the assessment and go through the form. Thank you, everyone.